Kia ora. Hi, it's me, your teacher. This video is looking at naming simple branched alkanes. So alkanes that have got a side chain or like an extra bit of some kind, but just really simple ones that only have kind of one extra thing stuck onto it. So with our branched chain, so you can see here I've got a straight chain here of 5 carbons, but I also have this extra friend up here just hanging out. This is an extra carbon, it's not a hydrogen, which means that we need to explain to our reader, our person that's going to try and draw this molecule after we've named it, that that's present. So if we were to go about naming this the way that we name a normal straight chain alkane, we would start thinking, how many carbons are in my longest chain? Well, I've got 5 carbons in my longest chain. And my functional group is that this is an alkane. I've only got single carbon-carbon bonds, so that means this must be an alkane. But if I were to give just that information to my reader, if I was to say that this is just pentane, my reader would not know to draw this extra part here. So I need to make sure I tell my reader what the side chain is, because it's not always going to be a CH3 group, but in this case it is. And I need to tell them where they are, because that CH3 group could be attached to any of those middle 3 carbons, and I would need to let my reader know exactly where. So it is currently on the 2nd or 4th carbon, and we'll come back to how we choose that later. So to remind ourselves that we need to, oh my gosh, my brain just stopped working, of our prefixes for number of carbons. So I reminded you, or I told you for the first time, I didn't remind you, in the last video that our prefixes for our numbers of carbon is something that we can use across functional groups and also for carbon side chains. So luckily, we don't have to learn new prefixes for numbers of carbons in a chain, because we already know them. We learned them in the last video. So I'm going to go through them again. So 1 carbon, meth, 2 carbons, eth, 3 carbons, prop, 4 carbons, bute, and remember that's mice eat peanut butter. And then we're into our shape naming, pent, like pentagon, hex, hept, and oct. So we're going to use these as a way to help us identify our side chain. So we can see here that we have only got 1 carbon in our side chain, 1 CH3 group, but we could have 2 carbons in that side chain or 3 carbons in that side chain, and we need to make sure that our reader knows exactly how many are present. So what we do is we take our prefix like we do normally for our straight chain, and our suffix, instead of being ane in this case, because it's not 2 alkanes joined together, it's a branch of a single alkane, is -ile. So this -ile here, or -il, depending on how you say it, some people say methyl, some people say methyl, some people say methyl. Up to you how you want to pronounce it, as long as you write it down properly, it doesn't really matter. This tells us that it is a carbon side chain. You can have side chains that are not made up of carbon, as you'll come to in your haloalkanes, but in this case, and for all of the ones that I'm doing in the next couple of videos, will be carbon ones. So the -ile tells us that it's carbon, and the prefix tells us how many carbons are present. So in this case, we have got 1 carbon, and it's a side chain, so we would name this a methyl side chain. So meth, a single carbon, -ile for carbon side chain. I'm hoping you can kind of see how this is kind of like a code or like a language. Each part of the words means something. It's all important, and it all tells us information about this molecule. So meth, 1 carbon, -ile, carbon side chain. So our next thing here is we have to tell our reader where on our molecule this side chain is. So we've told them that there is one and that it's 1 carbon long, but we haven't told them where it is and how they could draw it. So here we have to think about numbering our carbons and assigning the carbons in our straight chain, in our longest chain, a value or a priority. So this will not always be left to right. In fact, probably only like half the time it will be left to right, 1 to 5. You choose your number one carbon, your most important carbon, is the carbon that is closest, so the carbon end that is closest to the most interesting thing. So hydrogens are not interesting, boring. I spelled boring wrong, sad. But a CH3 group, a methyl group, wow, exciting, cool, different. So that CH3 group is interesting. And so we're going to label the carbon end that is closest to it as carbon number 1. So that means that this carbon here is going to be carbon number 1. And the one at the other end is not, because that one is too far away from the interesting thing. So if this is carbon number 1, that means the one immediately next to it must be number 2, and so on down to the other end. So it's always going to follow in sequential order. You're not going to get carbon numbers jumbled up. Once you've decided which carbon is the most important carbon, because it's closest to the most interesting thing, the rest of them will just follow suit. So nice and easy. So this is really helpful because it can then help us explain to our reader where that methyl group is. So we've already determined that we have a methyl group because we did that in the previous section, and we know that this molecule is pentane because we learned that in our previous video. I've got 5 carbons and all of my carbons are single bonded. That doesn't change just because it's got a side chain. So my longest chain has got 5 carbons. It doesn't matter that I've got the 6th one up here because we're dealing with that in the methyl. So 5 carbons in my longest chain, pentane. I've got a methyl group, and that methyl group is on carbon number 2. So if I go through this, pick a different color, not that color, it's a bad color, orange. If I go through this, this tells me that there are 5 carbons in my main chain, and they are all single bonded carbon-carbon. So pent, 5 carbons, ane, single bonds. And then this tells me that on the second carbon there is a CH3 group. So 2-methylpentane, if I gave that to another person, they would be able to draw this molecule. I've given them all the information they need, 5 carbons in the longest chain, and on the second carbon there's a CH3 group. So I'm going to give you some to practice down here, just like in the other video. So you'll notice that B has got a 2 carbon side chain. So remember the rules for naming the number of carbons in a side chain. It's the same as naming the number of carbons in a main chain. So I'll give you a couple of seconds, pause the video, come back, and then I will give you the answers. Okay, I assume you've paused and come back and are not just waiting for me to tell you. So here, I always name the longest chain first, because sometimes, as I'll show you in the next video, it can be kind of tricky to work out what the longest chain actually is. So it's the longest unbroken chain, and to kind of put that into perspective, as an example, I could choose this to be my longest chain, so this kind of L shape here, as 1, 2, 3, 4, 5 carbons, alongside this one being my longest chain. So 1, 2, 3, 4, 5. They've both got 5 carbons, so it doesn't really matter which one I choose. But if this one had an extra carbon here, my longest chain would actually be 1, 2, 3, 4, 5, 6. So it's important to look at how they've been drawn and to work out the longest unbroken chain, but we'll get into that more in the next video. So this one here, we start with our longest chain, which in this case is 3 carbons long. So that is prop for 3 carbons, ane for alkane for single bonds. And on my second carbon, and it doesn't really matter which one of these we pick to be carbon number 1 because the methyl group is in the middle. So on carbon number 2, I have got a methyl group. So on carbon number 2, there is a CH3 group present, and there are 3 carbons in my longest chain. Now this one's a little bit tricksy because you can actually, and it's more correct to just write methyl propane, because if this CH3 group was actually on carbon number 1 or on carbon number 3, my longest chain would be 4 carbons long and it would actually just be butane. So you can never have a 1-methyl propane or a 3-methyl propane because that's just butane. It's 4 carbons in a line. It doesn't matter if you draw it in an L shape, it's still an unbroken chain of 4 carbons. However, the only place you can actually have a methyl group on a propane molecule is in the middle, because it's the only place that doesn't just turn it into a longer chain. Anyway, if you wrote 2-methylpropane, totally fine for our learning purposes at the moment. So here, I again start with your longest chain, and in both directions, the L shape and the straight line, it is 5 carbons. So 5 carbons is pentane. And then I can see here, again, it's on the middle carbon, which means I can choose either carbon as my number 1. So I'm just going to start from the left-hand side because I haven't done that yet. So I can see here that on the 3rd carbon, I've got my side chain. And I have got 2 carbons in my side chain. So remember, mice eat peanut butter, meth, eth, prop, bute. I've got 2 carbons in my side chain, which means it's an eth, not a meth this time. So it's going to be 3-ethylpentane, or 3-ethylpentane, or however you want to say it. So on carbon number 3, there is a 2-carbon chain, and the longest chain is 5 carbons long, and all of them are single bonded. I'm really hoping you can kind of see how this code doesn't have any extraneous information. It's all important information that we need in order to be able to understand what this molecule is. All right, now last one here, I've got 1, 2, 3, 4, 5, 6 carbons. So this is going to be a hexane, because again, still just single carbon-carbon bonds. I can see that either the 5th or the 2nd carbon are going to be my methyl group, but again, we want to name carbon number 1 as the carbon that's closest to the most interesting thing, which means that this carbon at the end on the right is going to be my carbon number 1. So that means that this is going to be 2-methyl hexane. So on my 2nd carbon, there is a single carbon side chain. There are 6 carbons in my longest chain, and they are all single bonded together. Cool. I hope that was helpful. Let me know if it wasn't. Kia ora.